Hi everyone, my name is Vaverko and I'm going to talk about how we converted our .NET Framework APIs into .NET Core. So I work at Cultura and I'm also a father. I like everything about software. That's my main hobby right now, is writing code, understanding software architecture, so on. I'm the author of CodeSkunk. That's a nice blog that I post any new challenges that I find myself tackling. And Cultura has been my home for the past 3 years, and we're doing great things there. So Cultura is an OTT platform provider. Okay, OTT, it's over the top. We provide a platform for different media and telecom companies to provide their TV services over the cloud. So cloud TV provider, if you will. We also have other video businesses with education-related companies. We manage lots of assets. We spread all around the world with different offices. And our latest partnership with Solbergsoft is going to open up an offshore center in Minsk. We're looking for lots of developers and QA personnel to establish that center. And if it's something that you're interested in, be sure to visit our careers page and give us a ping. So what we're going to talk about today, let's talk about why we're going to refactor our .NET APIs, .NET Framework APIs at all. What are we going to gain from that? In addition, we're going to show you some helpful tools that we at Cultura gathered along the way. And when we get into the code conversion itself, I'm going to give you a few tips that we gathered. We see that are the most important one or difficult to figure out how to solve. And we're going to Dockerize everything at the end. So I really hope that the next 45 minutes will be of interest to you and you'll gain a few valuable knowledge key points from here. Right. So why are we going to refactor our .NET framework? It's working, right? So first of all, we're looking at operational cost perspective. Windows costs much more than Linux. And if we will convert anything from .NET Framework to .NET Core, we can run our workloads, our payloads on Linux servers, which are much, much cheaper than Windows servers. And it opened up a whole new world to run on ARM architecture and so on. And if you're cloud related, then you know how significant the cost reduction is. In addition, Linux it works faster than Windows in many key points, from the file system into network handling, concurrent requests, and so on. And we actually saw a multiply of almost 2 in increase of throughput of a single payload running on Linux versus running on Windows on .NET Framework. So the performance increase is significant, and it's something that you want to invest in as well. Without changing any logic, we got X2 performance throughput increase. So we need less servers, again, talking about costs. And last thing, you want to go Docker. You don't want to keep it on Windows, okay? It's not working really nicely with Windows. Docker is much smoother on Linux, and it's much natively supported on Linux operating systems. Although the last couple of years, there are good steps forward in Windows platform to support Docker, or basically to support Linux under Windows. So that's cool as well. All right, so we can refactor. Now we can start writing code, but hold on your horses here, because first of all, we need it quickly. We can't take 2 years off and not develop anything and just refactor the entire 10-year worth of code base. And the code base is really old, okay? It's been patched over the years with more and more services and more logic, and it's became just a huge monolith that we want to break later into microservices and so on. So right now, we need to keep the backend as is. We just need to convert everything to .NET Core and to work with containers in Linux. That's the main goal, to achieve stability and cost reduction. And by the way, we need to keep the old code running because we really want to run in parallel with the 2 payloads. So don't mess up the branch and don't mess up the GitHub repo entirely, because new features are still going to be developed as you do the conversion and so on. So it's it's going to be a real challenge here. Then let's tackle the challenge together, and we'll show you all the tips and tricks of how you can convert incrementally your code base into .NET Core without halting all the development and just digging into converting for a few months. So first of all, let's talk about tools. We have few tools that we covered. One tool is by Vaverko, and it's called CSProj to VS 2017. It's actually migrate 2019 now. That's the command line, but that's the repo name. The repo name is CSProj to VS 217, and basically it converts CSProj files from the old format, where you had to include every CS file, every reference, and everything into the CSProj, to a new 2017 and 2019 like CSProj file that has the nuget package references inside and everything. So that's a nice tool that automatically converts the projects doing all the nasty work automatically. Another tool is the .NET Portability Analyzer that's built into the Professional Visual Studio Development IDE. I'm not going to show you how it's done. You can figure out this in the docs, but it's a nice way of figuring out what's your starting point when you go into converting your legacy. It really gave us a map of what we should tackle first and what we should convert first, all the hard points, where we had third-party software libraries that are not supported by Linux and so on. So that's a really nice tool that helps you to start up this conversion process. And the last thing is a bash script that we wrote that will help us to clean some cache objects from our repo, from our folder. Visual Studio caches a lot of things, and they're framework related. So when you switch from .NET Framework to .NET Core, even if you switch branches, all the obj folder and the .vs folder that are hidden maintain different cache items that's making it really hard for Visual Studio to keep track of what real framework you're working on and reload the projects again and again. So that's a nice cleaner script that will help you to do a clean slate and avoid different compilation errors unwanted. After talking about the tools, we're going to talk about different tips converting the code base. So the first thing that we tackled is the HTTP context. And each one of you that ever worked in the legacy .NET Framework Web API saw the HTTP context current items line that basically stores lots of stuff for the request session. We had gazillion lines like that in our code base. And we converted to .NET Core, and we found out that .NET Core does not have the concept of a static HTTP context. Everything is dependency injectable. So you just need to inject the HttpContextAccessor. But nothing works with dependency injection right now. And introducing dependency injection into our legacy code base was just major refactoring that we couldn't stand and would halt the development for months and months ahead. So we found a workaround for that, and I'm going to show you that, which will allow us to go into Linux first and then take the time to refactor everything to dependency injection properly. Another thing is SOAP. Yes, we still use SOAP for different legacy servers that some clients require. And .NET Core does not support SOAP at all. .NET Core has dropped support for WCF, for Windows Communication Foundation entirely. There are a few community-based projects that are starting to emerge and try to restart this framework again under .NET Core. They actually have the support of the Microsoft Foundation, but they're still in early stages. One library that fits really well with us was SOAP Core. SOAP Core is not a stand-in for WCF, but it really helped us to convert our WCF projects into .NET Core applications that know how to receive and return SOAP envelopes. It's still not perfect, but it's really close, and it really allowed us to convert many SOAP applications into .NET Core. And the last thing that we saw, that when we converted everything and we started load testing, we saw a break at some point. So the API handled requests until a certain point where it just dropped and became unresponsive. And we started researching what's happening there. There are a few issues here under the ASP.NET Core GitHub that I've started, a few threads that are very interesting to read. And we figured out that the reason was thread pool starvation. So basically what you have is you have many concurrent requests coming into your API, and the pipeline of your .NET Core API is async, non-blocking. So the TPL library, the thread pool scheduler, will just handle this async non-blockingly, while when you get to the point of calling the legacy controller that calls the database in a sync manner, you're blocking that request thread. And when it gets back to the pipeline, and the pipeline is async again, non-blocking, so it returns as a callback and a await call, and basically it trying to get the thread to return the response to the client. But it doesn't have a thread because all threads are already blocked on the request, and all the requests that just came back and want to return to the client doesn't have any threads to return on. So what happened is that the thread pool scheduler will try to inject more threads, and this is what you see when you do some profiling. You see the thread pool injecting more and more threads as time goes on, but unfortunately the rate at which the thread pool scheduler injects new threads is much slower than the rate of the requests coming in, and it's not enough, and you get thread pool starvation, and the API becomes non-responsive at all, and it will take time for him to recover, or you can just reset the server. And there's a nice piece of software that was written by Microsoft MVP specialist. It's called the Microsoft ASP.NET Core concurrency limiter. It's a middleware that you snaps in into your pipeline, and it basically handles a queue of incoming requests while maintaining semaphores that will keep a limited amount of concurrent requests going through to the controllers. So it's nice when you have this sync over async code that you still don't want to refactor async all the way to become fully non-blocking, but you do want to go .NET Core and Linux. Again, nice tool, nice things, very valuable knowledge there. Just go there and check out this issue. The last thing that we saw that when we try to build it, today it's not really an issue, but if any of you will tackle that with working with older versions, when you try to build something and it's a dual framework, okay, you get an error message where I have a friend with a Mac that tried to build our project and got the error message that it's trying to build a .NET Framework project when it was .NET Core, but you'll have to add a condition here that will allow you to Dockerize and build everything under Linux for the CSproj files. And this condition basically says that if you're not building on Windows, if you're not currently running on Windows, do not build the .NET Framework, just build the .NET Core part of the application. Right, so that's what we're gonna see. Let's check out some code, and I've created a repo here. It's a public repository that you can clone and reference. Basically, the repo right now is its final stage where we have all the API already implemented. Right, so you have all the comments here that basically show you the history of converting an initial .NET Framework code application. It's a simple sample application of WebApi and SOAP service up to the point where it has concurrency limiter and it has Docker and everything is working. Right, so I've cloned this repo already and I've resetted my head into the base of the repo, the starting point. So we have the solution here and we have the clean solution script. That's a very nice script that will help you to clean the solution. And the solution here has lots of bin and obj folders and .vs folder that you will need to clean whenever you go from branch to branch. So that's a very important thing that you'll need to rerun every time you get changes in your API. Right, so I'm going to run it right now. And okay. So what we have here is simple application, two applications. One is a WebApi.NET Framework and the other one is SOAP service. So let's start up this one. And I'll show you that's a basic implementation of just a simple controller action that's available under API/data. And the API data will return you a list of users. So that's the basic API that we have. And it's a plain API with a global ASAX that registers controllers with a default path and everything. It has simple data controller that just returns a list of users from a user manager, and the user manager just has a static list of users to return. And it has some sleep timer here to show you as if it was a database call. Right, and we also have a SOAP service called ingest here that's implementing SOAP API, okay, with the SVC file, and both of them using a logging library. There's a K-logging library, that the logging library is heavily reliant on the HTTP current context items. It stores different variables there to format the message evenly and show you logs of that message with things like trace identifier and logging and the server name and stuff like that. So if I go back to my logs, right, and I'm gonna remove all the logs here. I have one running, so it can be removed. So let me just exit this. All right, I'm gonna remove that. Okay, and if I rerun the app, I'm gonna see a new file here created with a simple log that's showing me the server and the request ID and stuff like that. So if I'm gonna go to API data, you're gonna see the request hit here with a GUID. That GUID is the correlation ID of the request, that's helping you to trace the request along different services. So that's cool. That's what we have here. And first of all, we're going to run the tool to convert .NET into .NET Core. So I'm going to close the Visual Studio for now, stop the debugger. And there's something that I've added here. Where is this? That's code, .NET Summit, right. If you go into the command prompt, okay, and you go ahead and install the .NET tool, okay, let's review this. That's the first tool that we're going to talk about. So that's tool, and we're going to go into this link here, and there are a few instructions here on how you install this tool. Okay, so if you go ahead and install this tool on your machine with .NET Core, I already have it installed. I'm going to just go to the logger, and I'm going to go ahead and run the tool with the command .NET migrate 2019. That's the name of the tool. The command will be migrate. Okay, and the target framework will be tnet 461. That's my current network. That's my current target framework. And an additional one, netcore app 3.1. Okay, so before that, just want to show you the logger CSproj file is an enormous CSproj file with the old format where you have the GUI, the platform, all the files that are included, the references, and so on. Okay, right now when I'm going to run this tool, okay, it's going to create a backup of the original inside backup, okay, with all files, and the CSproj right now is going to look much cleaner. Okay, you can see that right now it has multiple target frameworks with an S. It's target frameworks, multiple frameworks. It's going to be built for both .NET Framework 4.61 and .NET Core App. And there are a bunch of other stuff that were taken from. You can safely remove them if you know that you're using the defaults and so on. One thing that already also happened here are the item groups that left the references for System Web and Microsoft C# and SystemNet HTTP. Those files are not supported in NetCore, so you'll have to tweak them a little bit. And this is where I move to the next stage of my Git repo after we ran this. So I'm going to reset my branch to here, reset hard, discard all changes, and we're going to review the CSproj file of the logger one more time. So the CSproj file on the logger after running the .NET Core project, okay, you can see that I've added a condition here for all the included references that they're only going to work with Target Framework 4.61, okay? And right now, if you're going to try and compile the project, you're going to right, so you can see that the logger was converted, and I'm going to go into the next branch here. I'm going to reset hard, right? And this is where we introduced the issue with the HTTP context. So if I'm going to open up Visual Studio, okay, I'm going to run the clean solution just to clean everything up. And you can see that right now, the logger file has multiple target frameworks, as we saw previously, okay? But we have all the previous references under target framework equals net461, okay? And we have a special project that we created called static HTTP context for net core and 3.1. So the static HTTP context, if I'm actually going to remove that and show you the issues that we have, okay? And the keylogger, you're going to see that there are errors here, right, in the project, but you don't see the errors at all, just because you need to switch frameworks, okay? This is how you switch in a multi-targeted framework environment. So you switch to NetCore 3.1, and you see that HTTP context current is not available under your framework, okay? So if I go back and bring back this magical project back, I'll show you how it works. And now we have HTTP context current under .NET 3.1. So the static HTTP context is basically a shim over ASP Web. It was inspired by some blog article that I read. And it's a shim around system.web HTTP context. And that's a project that is built only for .NET Core application, right? And when we create the HTTP context, we have a static configure method that will accept the accessor for the .NET framework code. And when somebody will ask for the current HTTP context, it in turn will ask the accessor to retrieve the HTTP context. Okay, so that's a basic shim, and that's going to work because the HTTP context accessor is using actual thread local variable that will keep the current HTTP context, the logical thread context, in place, and will help you to use static accessor without going through all of the libraries. Right here I have a simple single library, but you probably have much more of them. So this logger will be allowed to use HTTP context current. So right now I don't have a .NET framework application to use it, but everything compiles, okay? The logger compiles and the API app compiles, and it still works. And I have my first project converted to support .NET Core and 4.61. And this is the basic milestone. This is how you go project by project, library by library, and convert each and every one of them to support both frameworks. So the previous API keeps working. Right, next step. The next step will be to split all of the core logic / API controllers and data from inside the API into separate libraries that support both framework and ASP.NET Core. So we probably have some controllers here, and we probably have the DAL. Maybe the DAL is already separated, probably it is. We have filters, we have models and stuff like that. Everything needs to be separated into its own project and loaded from a separate assembly. And this is our next comment. So moving to the next comment here. And running the clean solution. All right. Reloading everything. Cool. So we have everything reloaded. What we have here is we split the API controllers into a separate API controller. I'm going to talk about this in a minute. And I split the API models into a separate, and I split the data access layer into a separate project as well. So in the API app, to support loading controllers from an external source, I obviously needed to include the namespace API controllers as the default namespace to the ASP.NET framework, the MVC network, to search for controllers. So the data controller here, all of the projects are both .NET Framework and .NET Core projects, okay, again, multi-targeted. And the main problem here is the controllers thing. The controller thing has different frameworks, but fortunately they have same names for different classes. So we have different NuGet packages that are used for .NET Core 3.1 and different NuGet packages and assembly references, framework assembly references for using .NET 4.6.1. And whenever you hit a wall and you have a using statement that's supported only in .NET Core, you can always use the sharp if to decorate this using statement. And this is used to allow us using the HTTP GET from the 6.1 network that's coming from WebHTTP and versus this one that is coming from ASP MVC Core under different framework. Right, so that's the main split into different controllers. Next step will be to add our new NetCore API. So I'm going to reset this branch to here. And again, I'm going to clean the solution and reload it. Okay. Oops, sorry about that. So right now, what we saw is something that helped us to facilitate the controllers to be compatible for both APIs. Okay. So the ASP.NET Core application requires us to route the controllers with attribute. If you want, you can use default routing, you can use attribute routing, but most of us use attribute routing under .NET Core. And it requires us to use controller base as our base class for defining an API controller. Whereas in WebAPI framework, you need to inherit from API controller to define an API controller. So that's a base controller that we have defined that splits by network, by framework, and inherits from a different API controller. Then the actual data controller is inherited from base API controller. Okay, and that really helps. Another point is if you want to do a compatibility shim, and if you just need the namespace in a using statement to be supported in both networks, and you do not want to copy paste this code into multiple pages. So if I'm going to remove this, you're going to see that this is here going to make us problems. So if I'm going to go to NetCore 3. To here, sorry, here, right. So this one, base API controller, the controllers here are defined from different namespaces. Okay, the ASP.NET Core MVC controller contains the base, while it doesn't know what's HTTP web, and this one contains something different. So I can do and split those using statements into those separate sharp if, but I really wanted to show you a different way of doing compatibility when just using frameworks, when you need to make the using statements compact and keep them the same across all projects. So this compatibility shim will allow you to define namespaces, empty namespaces for both of them. And that's a pattern that returning on itself when you need to shim something for Net Core application to know about something that exists in Net Framework or vice versa. Right, so right now we have an API controller and we created a new Net Core application. We didn't touch, from the previous step, we didn't touch our Web API project. The Web API project stayed the same, exactly the same, and is still working, okay? And the ASP.NET Core application is the new one. In that application, you can see the startup file that actually defined an endpoint under API with a default controller routing, okay? And this is something that I don't know how many of you know, but probably when you define your controllers from a different assembly and you want to reuse them in multiple projects, similar to what you do in WebAPI in the global ASEX file, where you define the current namespace, default namespace for MVC framework to search for control implementation. In .NET Core, you do that by adding an application part, okay? So what you do is basically you take one of the controllers in the assembly and you get just to get the assembly object of the controller, and you load it into the application parts after you added the controllers, okay, when inside the IMVC builder, using the IMVC builder interface. So this is how you can add your controllers and services. And now, if I use the .NET Core API app, and I'm going to launch it. Okay, the API app is going to bring up this console menu for the API, and I'm going to see my data in a few minutes. Right, there you go. You have the data, and you have in C log .NET Summit, you have the app log working flawlessly. Right. So what we covered so far is we created the WebAPI project, we created the .NET Core project that mimics the WebAPI and is reusing the same logic. Okay, I just restructured the logic into separate projects. I never actually did major refactoring on my controllers, didn't change the logic, and if anything, the most significant change was the introduction of the base API controller, that I needed to just go search and replace my entire code from using API controller into using base API controller. And it's not a significant change at all. And using shims and using the static HttpContextAccessor, it allowed me to convert to .NET Core. Okay. Next step is going to be the SOAP. So I'm going to jump a few more comments here. One is adding the log and trace identifier into .NET Core. So you remember the static HTTP context? We need to configure it. So if I reload the project right now, and there's a web application here that needs to be removed. Under startup here, you're going to notice that after I've added the static HttpContextAccessor, I've took the accessor and I called upon the configure method of the system web HTTP object that we created. This is the shim that we created here from the static HttpContextAccessor. This is how I configured it, and then I have added HTTP context into my application in that method. Okay. Then I added a new middleware that inserts into the current context the request ID for the trace identifier. Okay, and added the logging. So if I run this right now, both APIs using same trace ID, same logging library. Okay, I'm going to have a new log here. Wait, log, right? And WebAPI Net Core log, right? And I have the trace identifier in the .NET Core manner already logged out using the same logging library, using same components. Okay, nice. So we have this .NET Core project up and running, and next thing is to tackle the SOAP API. And the SOAP API is where we split the ingest SOAP into an ingest common library, again splitting the logic into two separate projects. So I'm going to split this, going to load it, reload it, and you're going to see a new project here called ingest common. So the ingest only includes the SVC file. That's all it is. Okay. And what we have here is all the models and the iService definition, the operation contract as defined here. Of course, I didn't add any significant implementation, but if you have an implementation here of the SVC file, right, you'll have to move it as well to a common library. But probably you have some call to a logic library here that's already common and already converted both to .NET Core and .NET Framework in both cases. So here, the ingest common library is available here, and I have a few compilation errors because it didn't run the clean script, but it's not the point here. After I've splitted the logic here, I'm gonna again load the create new ingest.NET Core project, and I'm gonna show you how we use the SOAP Core NuGet package to help us serve SOAP APIs using .NET Core. Right. So we're loading this solution. Okay, cool. Right. Now we have ingest.NET Core, and ingest.NET Core in his startup file again is a basic startup .NET Core project. Okay. The only thing that we did, we added the scope service. Usually it will be scope. It doesn't have to be scope. If you know you're good with a singleton, you can use a singleton, it's dependency injection wise. But I've added the ingest service, right, as the service implementation for the ingest iService interface, the operation contract from ingest common, okay? And what I did next is to use SOAP core, okay, this one, use SOAP endpoint from the SOAP core library, okay, that's SOAP core. It has nice middleware called use SOAP endpoint, and the use SOAP endpoint will accept a binding, okay. We usually use HTTP binding, basic HTTP binding, and you can define all the certificates and reconfigure everything you need here. And basically, it gives you a way to define an endpoint at which a WSDL file will be served. So if I run this, if I run the ingest netcore, I'm going to have myself a WSDL file up and running. And if I really want to, I'm going to go to Postman, and I have some tricky way to send out a request in a SOAP envelope. So here we have a post request, right, with the envelope body. Oops, sorry, we don't have it. There is the SOAP action. No, we don't have it. Let me check the history. I do have it somewhere here. There it is. All right. So we have this SOAP body request. Okay. I'm going to move it to here. I'm going to use row XML here. And one more thing that you need to add is to add the SOAP action called ingest data. This is how my operation is called. I'm going to fire out this envelope, and I'm going to get a SOAP envelope in response from my .NET Core service here. Okay, that's currently running. Okay, so we've used SOAP core, and we've used all of the previous library converted, such as the HttpContextAccessor and the log library that we've converted inside this project as well. And that's basically concludes everything. We have last thing to talk about, and that's Dockerizing everything. So if I'm gonna go here and I'm gonna reset the branch to Docker, you're gonna see that the Docker file has been added here, and it's a simple Docker file. It basically has two-stage builder, right? It's using the Alpine image to build, and then using the Alpine runtime to run the application in a given port from an environment variable, and then it exposes the same port. Right, so that's the Docker file, and if you want to, we're short on time, but if you want to, in the README file, the README MD file, I have added steps of how to install the tools, how to use the .NET Migrate, different ways of splitting the controllers project, and so on. There's the Docker build commands, okay? Oops, sorry. There's the Docker build commands and the Docker run command, and there's the bombardier command that you can bombard the application and try to figure out the concurrency limiter and how it works, and how that changes from one to the other. And the last commit is when we snap the concurrency limiter on. You can see that right here in ASP.NET Core under startup. You do two things. First of all, you define a queue service, okay, queue policy. Actually, first of all, you add a NuGet called Microsoft ASP.NET Core concurrency limiter, the appropriate version, and you add a queue policy to the services. There's queue policy and there's a stack policy. Okay, services, stack, and you can add stack policy or queue policy, and they both have similar configuration. So you have max concurrent request, and you really want to set it to processor count, or processor count multiplied by 2, okay, because that's the amount of concurrent requests that you can handle really in parallel, given your CPU. Any higher than that, you're going to suffer from lock contentation and context switching. And you're going to get another property here, that's the request queue limit. and any request that if the queue gets higher than that, the service is going to return 503 responses, the service unavailable. And after you configured the policy for the concurrency limiter, you then just snap in the concurrency limiter in your relevant application pipeline using this use concurrency limiter API that's taken from this wonderful NuGet package. And that really helps you with thread pool starvation and really gives you a good configuration handle on how many requests are coming in and to handle this load when you have sync over async with blocking APIs in your legacy code. Right, so that covers our demo. I'll be happy to answer any questions you have in the QA room. Feel free to ping me or open up issues inside this public repository. I'll try to get into it and try to fix those issues as we go along. And that's it. Thank you all for listening.